Hello. So, good afternoon, everyone. Today I'm uh, uh, going through the live session 5. So, today we'll discuss about the types and applications of the nano and microfluidic devices. So, moving to the like concepts, we'll just discuss what are the different uh, types of devices are there. So, based on research field and various design, we can distinguish these microfluidic devices. So here we are discussing about the based on the research field. So chemical and materials is one of the prolific area for the microfluidic devices where it will be used for the surface modification, pattern repeatability, surface plasmon resonance. The second one is the mechanical and fabrication technique. In this field, to construct the microfluidic device, we are using the soft lithography, deformable microchannels, and fluidic structure interactions. We are studying. For the biological and lab on chip uh, field, the microfluidic device used for the in vitro model, flow cytometry, low cost diagnostic. Then biomimetics, sensors and actuators, miscellaneous field has been also established in this uh, direction. So here is the chemical and material uh, 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 field where the like, in this chemical and material the microfluidic device has been used as a suppose as generation of the emulsion in a coated and functional PDMS. So these are the PDMS based microfluidic channels. What is happening here? This the water and toluene will be mixed. So these are the uh, toluene, and here this is the channel for the water. So it will form the bubbles and it will be look like this. These are the water bubbles inside the solvent solvent, and that is going to through the microfluidic device. Here another way is that toluene is going through with the water with water. So this through this channel the water is flowing and here toluene is injected. That is making the emulsion. Another field is mechanical and fabrications where the microfluidic device has been used for the electrical analogous of the electrical component to mimic that. And here you can see the PPA is showing the input reservoirs capacitors. These capacitors are single like capacitor works on the single auxiliary pressure source where the input reservoir generates uh, input reservoir. We are inputting the fluid and that goes to the input capacitor where the when we are giving the vacuum that time it will be flow will be more and the another is the diode where it is this diode. The diode is like when we are giving the vacuum then it will allow the fluid to flow. Then the output is like we'll get here the output in the end, and this is the deformable PDMS layer. The another example of the field-based microfluidic device is the biological one, so where this pattern cancer cells have having the how it is uh, like sorting with the cytometry. So, so it can be cytometry method includes cell size, cell count, cell morphology, and cell cycle phase, DNA content, and other adjustment and the absence of specific protein in the cell surface or in the cytoplasm. For that, there will be a three different categories of cell, with a basal, luminal, and stem cell-like. Then it will grow in the 3D substrate and will give the repeat treatment. Then culture expansion happens in this. Then in the end, the flow cytometry is there, analyze cell co uh, cell phenotype equilibrium on different videos. Then another one is biomimetic. Solid is L-lactic, so glycoside PLGA. Then another one is the biological one, so where the uh, it is used for the DNA transcription and fluorescence will be used to sense the cell. Another example is the sensor and actuator, where the cell has the cell will be mimicked to uh, the PDMS based microfluidic device will be mimicked to the electronic components such as this rectifier. You can see how they have fabricated the bridge rectifier using this um, loops, and also they have done the compression and tension test using this bridge rectifier. Another sensor and actuator is like where the light, the particles of 100 nanometer and 300 nanometer will flow in the one direction, and because of the flow, the small particles will propagate in the one direction, and uh, the 300 nanometer particles will fluctuate using the piezo state, and that will flow in the it will bend in the one some angle, and it will separate to the small particle compared to the last particle. Various design of microfluidic devices has been shown here. So 3D printed multi material wall, 3D printed micro mixture, 3D printed syringe pump for pneumatic control, then macula mixture, microfluidics, light, culture tube, X mixture, sorting device for living organisms based on electric field, point of care, ocular, rapid test, then applications. So mostly the successful implementation of the microfluidic has been done in this single cell profiling devices and material production printing, where uh, in first area they have done the uh, single cell analysis, next generation high throughput genetic sequencing, pregnancy test strip for monitoring blood glucose, urine test strip, then production of production material production printing, production of consistent lipid micro particle of drug relief flow through nozzle or mechanics of droplet formation or in droplet based printing application. Then promising area for the application of microfluidics are diagnostic, where we can see time sensitive diagnostic testing like a sepsis, infectious disease, especially during the pandemic, antibiotic susceptibility testing, then essential diagnostic test for low and middle uh, income countries, liquid biopsies for detection of rare biological species, genetic screening for test efficiency of prescribed medicines, therapeutic organ on chip for screening or therapeutic and their antibiotics, antibody discovery, profiling the human gut microbiome for discovery of marker of inflammatory bowel disease and other anti-immune disease, lipid nanoparticles, food and consumer productive safety, detection of misleadable misprinted food, identification of the foodborne bacteria, production and the formulation of the material, which is like synthesis of core cell particles, production of designer particles with controlled shape and composition, production of active pharmaceutical ingredients, continuous flow synthesis of toxic chemicals, anti-cities of proteins. So after the application, we will go for the modular microfluidics, where you can see this. There are the module library, connection method, and biological applications. So first, modular library, which we will discuss, where we are using the different components of the microfluidic device, such as valve, which can be used for the on-off to the device, then pump to flow the fluid, then mixture to mix the fluid, then separator to mix to separate the mixture of the fluid, and then droplet generator, gradient generator, then connection method has also been improved so much. So there are different kind of connection methods like a Lego connection where we can use the normal the plug and play one. Then tubing connection, Louis connection, O-ring gasket connection, adhesive connection, plasma connection. Then the biological applications has been grown with the development of the microfluidics, that is cell cancer isolation, PCR can be done, organ on chip, my, biomaker research, particles materials, this can be done using the uh, microfluidic device. Then this is uh, the wall which we have discussed in the previous uh, slide. So it can be it used for the on off to on off the circuit. So here the first one is the thermopneumatic microwave, where you will use still to heat this fluid, and it will if it will heat, then it will block the fluid uh, uh, propagation. But while the when it will cool down, then it will again start the fluid flow. Another one is based on the electrostatic, where the um, uh, electric field reports will be present in the top and bottom, where and top, bottom, and middle. Then when we apply the fuel BIOS, then it will act as a on-off micro. Then piezo, where this piezo material will be used to block and flow the material fluid. And another one is the electromagnetic wall, where this coil is having the um, like um, coil which generates the uh, magnetic field, dynamic magnetic field that acts for the electromagnetic microwave. Then another one is the hydrogel. So bigger hydrogel will block the my block the fluid and not allow the to flow. Then another one is the hydrogel which is only small that will allow easily. Then check one. So here the open and closed form will be there. The flat membrane is used for that. Then another one is a micro mixture. So we have discussed in the first slide of the component where we discussed about the one of every each and every component of the microfluidic. This is one of the important uh, uh, component for the microfluidic device where we are using this different we are using the different fluid and it can be mixed with the different ratio using the different various uh, techniques. The first one is showing that a parallel laminar micro mixture. So here it's like just here flow like pumping the fluid inside the microfluidic device and it will uh, generate the microgradient uh, fluid. So it will work in the principle. Another one is that it's having the barrier structure micromixture where the small barriers will be there in the middle of that. So the fluid will block and mix with each other and hence that's how this fluid will flow into the another direction. The another one is that in the staggered herringbone micromixture will be there where the fluid will flow in this um, direction where the blockage will be there. This herringbone will be allowed the it allows the one fluid to go to the another direction and the another one also to the uh, one direction. Vice versa also possible. That's how this micromixture works and will get the different ingredients. It also depends on the how the concentration and uh, how much flow rate we are giving to each other to both of the fluids. When droplet mixture will be there, this Y kind of shape will be there. Like will allow to mix the um, uh, like fluids, and another way it is having the either it is giving the pressure by air or just a laminar flow of the uh, uh, solvent. Then electrode mixture will be there. So electrohydrodynamic having the electrodes and that will allow to mix this fluid. And another one will be the electrokinetic injector. So here this kinetic electrically biased kinetics will go and that's how this micro mixture will work. Then this magnetic hydrodynamic mixture will be there. Micro mixture will work where this magnetic field will apply to the uh, fluid. It should be having the magnetic uh, magnetic uh, sensitivity through the solvent. Then another one is the acoustic mixture where we are using the piezoelectric transducer. This will generate the acoustic waves that gives this kind of thing uh, micro mixing. Another one is pressure actuators, which will generate the pressures perturbation, where it will generate the high and low pressures in the middle, and that's how this micro mixture works. There are another separators. There are another component. There is another component that is called separator. So here are different separators. So this is the DVP separator where we are using the electrode, and it will separate based on the electric field, positive and negative direction. Another one is the acoustic separator where it will uh, flow according to the acoustic wave. A particular frequency it will generate the channel flow, and that's how we can separate the um, material, liquid. The another one is the optical separator where we are using the optical tweezer. That tweezer will uh, act as a trap and that will take one of the fluid to uh, along with it, and the another one will flow continuously in the one direction. Then the D1 source is the magnetic separator where the magnetic field has been applied and that flows through the um, uh, microfluidic channel. There it will generate the separate that will separate based on the magnetic field uh, of the fluid. The another will be where the in this EFF separator the liquid particles uh, will, uh, will mix with the buffer fluid, and here this which like pinch segment and the broadened segment will allow to the suddenly the expand to the bigger area, bigger volume, then it will like separate easily. The another one is the TLD separator where the buffer and the liquid with particles will separate according to the uh, like flow of the channels. Then hydrodynamic filtration separator where the liquid particles will go with a branch point, and there uh, based on the affinity of the hydrodynamic, it will separate according to that. Then the last one is the inertial separator where it will use it will work based on the inertia, moment of inertia. So for that it should have the fluid should have in a high velocity and the mass should be different in the particles of uh, in the liquid particle size also should be different. Then this droplet generators we have discussed. So there are different kinds of droplet generators. This is the co-flow, this is cross flow, this is flow focusing. The another one is the DE, which is a DEP droplet generator, where the bias will be applied. Then the magnetic droplet generator, where this uh, magnetic field will be used to generate the droplet. It's upstream and this is downstream. It will work based on the uh, it can be used to determine the size. So if you keep an upstream, then it will take longer time to make a bubble and so make a droplet and that will flow. Whereas downstream, it will just quickly uh, uh, attract the small uh, flow. The another one is the acoustic droplet, where the acoustic is transducers, piezoelectric um, transducers will be there. That will generate the acoustic sound, and because of that, it will generate the droplets. The another one is the heater, where it will heat and it will quickly detach from the fluid, and that's how we will get this micro droplets. Then the another one is the laser droplet, where this laser will be used to make form the droplet. The next type of droplet generator is right, where this fluid will be having the hydraulic power compressed here. So based on that, it will compress and release, and that's how we'll get the mechanical droplet generator. There will be another part which is called gradient generator. So gradient generator is just like same like our droplet generator, but it's having the different mechanism. Where the first one is showing that a blank buffer and the stock solution input fluids, and based on that, it will having the gradient and the main solution, the main fluid, and this you can see the buffer side it is having the low stock solution concentration, and during it will go to the right side, the buffer blank buffer will be reduced and the stock solution concentration will be quite high. It can be used for the different various applications such as uh, change in the gradients of the uh, same uh, sample to detect very fast to diagnose the very to diagnose the cost. And the second one is the Y kind of Johnson gradient generator. Here the blank buffer and the stock solution will mix and flow to the another direction, and it generates then the again the gradient field. The next type of diffusion based buffer generator, where the stock solution and the buffer will be having the membrane um, separated by the membrane, and it will be slowly generate the gradient. Then the blank buffer, stock solution, low flow rate, high flow rate, and this kind of things can be used for the droplet based gradient generator. And for today, I think this is enough. Let's meet in the next week, and we'll discuss about more about the microfluidic channels, and also we'll discuss about the numerical questions that I will uh, continue in the next week. Thank you.